Lesson 4.1, Congruent Figures. Figures that have the same size and shape are called congruent figures. Just like we had congruent angles, those were the same angle measure. Congruent segments had the same length. Any figure that has the same size and shape we consider to be congruent. When two figures are congruent, you can slide, flip, or turn one so it exactly fits on the other one. For example, that we could take a look at this diagram here. We got a picture of a slide. If you slide something up, it's not going to change it. Flip it, it's not going to change it. And if you turn it or rotate it, it won't change the size or shape. It'll just change how it's oriented. You can determine whether two figures are congruent by comparing their corresponding parts. Remember when we talked about corresponding angles, they were in the same position. With corresponding parts, they're going to match up in the same position of each figure. When naming congruent figures, you must list the corresponding parts in the same order. So if you have a triangle, you're going to have 6 corresponding parts. 6 parts. You have 3 segments, there are 3 sides, and you have 3 angles. So if all 6 of the corresponding parts are congruent, then the triangles are congruent. So let's take a look at our example 1, naming corresponding parts. So we have a figure over here, and this one happens to be color-coded, but not every figure is going to be color-coded. So let's match all of our corresponding parts. So we'll start with the figure on the left, and we'll match it up with the figure on the right. So we'll start with angle A. It's going to be corresponding to which part? And that's going to be E. If you look over, this is a reflection, so it's going to match up with angle E. And then we take a look at the next one, angle B. Angle B is going to be corresponding to F. Then we go down around the figure to angle C. C is down here. It's going to flip over and match up with angle G. And then we have the last one, angle D, which is congruent to angle H. So now, these are all the corresponding angles. These are all the ones that match up with each other. Let's take a look at side lengths. Now from this you could make when you get all the angles, you can make what we call a congruency statement, which is what was written here. This tells you that figure ABCD is congruent to figure EFGH. And so each letter matches up with the one in the same order as the other one. So A is in the first, E is in the first, so they're both congruent, they're corresponding, they match up. A goes with E, B goes with F, C goes with G, and D goes with H. We can also see that as we wrote ours down here, ABCD matches up with EFGH. Now doing that, we can use to write down our segments. So let's take a look at this congruency statement and make our congruent segments. So AB is the first 2. It's going to match up with the first 2 here, which is EF. So AB congruent to EF. And then we could go, so we said the first 2 here, the first 2 here. Second 2, BC. It's going to correspond with the middle 2 here, which is FG. And then we can go the last 2, CD. It's going to match up with GH. And then it doesn't matter the order you take it in. You can go the first and third or the last and the first. So if I went DA, I would have to match it up with HE. So it's important that you do the corresponding order, so you know what part goes with what. So let's take a look at the next one. You try this one. So I want you to identify the corresponding parts by looking at your 2 diagrams. Let's start with the one on the left, work with the one on the right. And then I want you to write a congruency statement. Remember, a congruency statement is this statement that we had on our last slide, this statement right here. That's a congruency statement, so you're going to write one for this. So pause your video now, work it out, and come back and check how you did. All right, so we look at A. A has one congruent arc, so you're going to match it up with it has one congruent arc over here, which is M. B has 2, so T has 2. So we match those up. And then we have C, which has got 3, leaves us with X, who's got X. Has 3 as well. So we have ABC congruent to MTX. So that we're going to say the triangle ABC is congruent to triangle MTX. We can match them up just like this. And from there, it's easy to match up your segments. AB, first two, MT, the first two over here. BC is the middle and the last. TX is the middle and last. And first and last is going to be AC is going to match up with MX. Now another way to do this is if you looked at to match up your side links. We could say that since this is angle 1, I call it angle 1 because it's got one arc. We can say this is side 1 across from it. This has got two arcs, so we'll say this side across is side 2. And 3, C has 3, so we're going to say that's side 3. Now, if you do the same thing over here, this is going to be side 1, side 2, and side 3. Now, when you're matching these up, you can match up and say, okay, here's side 1. So AB is going to be the side 3, so it's going to match up with the side 3 over here. But you have to make sure you do it in the right order. So you have to look and say, okay, I got to start with M and then go to T. If you write your angles down like this, it's easier to match these up with your segments because they're already in order. You have a statement here. And even if you didn't have a picture and they give you a statement, you can write all this information down from this one given statement. All right, so let's take a look at using these congruent parts. So we have a picture of a plane. And their wings on here, they have two congruent triangles. So one thing we're going to do here is they want us to know what angle D is. So we got to figure out which one matches up. Now, if I look at this picture, I can tell real quick that angle B corresponds with angle E, so therefore those are congruent. And then I'm going to look down, I got A, which is on the outside, angle A. And this is a mirror image, then this A should match up and flip over to land on D. So A and D should be the ones that match up. And then we have the last one here, we have angle C, congruent to angle F. Now, so if you remember from when we learned about triangles, the sum of these is equal to 180. So if I have 30 and 75, I can add those two together and subtract it from 180 to get angle A. So angle A can be found by taking 180, and we're going to subtract out 30 plus 75. So that gives us 105 when we add those two together. Subtract it from 180, and that gives us 75, which happens to be the same as the other angle over here. So this is 75 here. So if we match up with the corresponding parts, this is 75 here, and therefore this is also 75 here. So what type of triangle does this make? Well, this makes an isosceles triangle because in isosceles triangles you have two sides that are congruent. Therefore, these two sides would be congruent. And therefore, and one thing about an isosceles triangle is that the angles across from these congruent sides are also congruent. All right, so I want you guys now to try this part. Find the measure of angle 1. So the sides of this roof suggest congruent triangles. When they say suggest congruent triangles, that means they are congruent triangles. So what is the measure of angle 1? Pause the video now, come back and check it when you're done. All right, so one thing you'll notice here is that 48, this is a right angle, so that's 90 degrees. So this is a triangle which adds up to 180. So we can find that by adding these two together to get 138. Subtract it from 180 and get 42. Now another way to get this angle measure is that in a triangle we studied all three angles here should add up to equal 180. Well, if you have a right angle in a triangle, you can only have one right angle because anything greater than that would not make it a triangle anymore. You'd make it some other type of figure. So if you look here, this is 90 degrees. Well, that's half the measure of a triangle. So that means these two have to equal the other half. So another way to get angle 1 is by taking 90 and subtracting the angle they have, which is 48, and that gives us 42 degrees. So we can get it from adding these two up and subtracting from 180, or by taking 90 minus the other angle they give us, and that gives us our third angle, 42 degrees. And since these are congruent triangles, and this is 48 over here, which means this is going to be 42 degrees. Let's look at our third angle theorem. If two angles of one triangle are congruent to two angles of another triangle, then their third angles is also congruent. So if this was a 30-degree angle, that's a 60-degree angle. Okay, add them together, that's going to be 90. So therefore, if these added up to be 90, then this would have to be a right angle. Now it's not, but just putting numbers in here, that's the way it would work out. So if A is congruent to D and B is congruent to E, then you know that angle C is congruent to F. So let's take a look at this. They want us to know find the value of the variable. Well, if I'm looking here, I look at all the information they give me. I give me these sides are congruent, these two sides are congruent, these two sides are congruent. This angle right here is 3x plus 2. So if these are congruent triangles, we have these two angles are congruent. And we know these two angles are congruent because they're vertical angles. So therefore, their third angles must also be congruent. So we have two congruent triangles, which means this is going to be 5x. And since these two are congruent, because they're marked so, this is going to be 74 degrees. So we know the sum of these is going to equal 180. So we can take 5x plus 74 plus 3x plus 2 is equal to 180. So all these three angles are going to add up to equal 180. So 5x and 3x is 8x. 74 and 2 is 76. Now subtract 76. 8x is equal to 104. Divide by 8. And x is going to equal 13. So, once we get 13, you could plug it back in to determine whether everything should add to equal 180, but we're only looking for the value of the variable, so our answer here would be x equals 13. All right, you guys try the next one. Pause the video, check your answer when you're done. Now, they want to know what is the values of the variables. We have y right here, we have x right here. We are not looking for the angle x or angle y. We're looking for this segment x, which is segment EF, and this angle right here, which is angle D, which is 2y. So if you look here, you can also see that Z is congruent to D, because if you look at the statement here, we have Z and D both in the last statement, so we know those are congruent. They correspond to one another. If this is 30, then this should equal 30. So 30 is equal to 2y. So we divide by 2 and get 15. So 15 is the value of y. Then if we look at xy and EF, those are going to be corresponding parts here. They match up. So 9 is equal to 3x. We divide by 3, and we get x is equal to 3. So that's the answer for x and y. All right, so let's take a look at these. We're going to find the measures of the given angles or the lengths. And so that means in order to find the measures of these angles, we have to find the value of x. So let's look at what we were given here. They tell us that triangle FGH is congruent to triangle QRS. So that means F goes with Q, G goes with R, and H goes with S. So they give us angle F and angle Q. Well, if we look back up here, F and Q are congruent. So that tells us that these two should equal each other. So angle F should be congruent to angle Q. So we're going to take their values, x plus 24, and set it equal to each other, and 3x, and put them equal. So now I'm going to subtract an x. 24 is equal to 2x, divided by 2, and that gives us that x is equal to 12. So that means that if we plug it back in, we're going to get 12 plus 24, which is going to give us 36, or 3 times 12, which gives us 36. So the measure of angle F is equal to the measure of angle Q, which is equal to 36 degrees. So look at your congruency statement to help determine what parts go together, which ones are our corresponding parts. All right. Let's go on to the next one, and you guys find the value of GH and RS. First, find the value of X, back and plug it in. All right, so if we set these up, we know GH is congruent to RS, so therefore they're congruent, set them equal to each other. 3x minus 2 is equal to x plus 6. Solve for x and we get 4. Then when we go back and plug that in, we get 4 plus 6 is 10, and 3 times 4 is 12. 12 minus 2 is 10. So GH is equal to RS, which is equal to 10. So let's go on to our last part, the proof. In this one here, they're giving us several statements this time in our given. And we're trying to prove that these two triangles are congruent. So as we look here, the first thing we look at is LM is congruent to LO, and MN is congruent to ON. So that is up in our given statement, so that we would say it is given. And now we have LN congruent to LN. Well, that means anytime we have anything congruent to itself, this is by the reflexive property. If you remember back in chapter 2 when we went over the properties, this was one of these that was highlighted, the reflexive property. So we have 3 sides that are congruent. Now we look at angles. Angle M congruent to angle O. Angle MLN congruent to OLN. Well, if you look up here, that is given, so that is another given statement. So now we're looking at this one here, angle MNL congruent to ONL. So why are these two congruent? Well, if 2 angles are congruent to, of one triangle are congruent to 2 angles of another triangle, then their third angles are congruent. So our reason for this would be the third angles theorem. And that brings us to our last one. Now we have 3 angles congruent to 3 angles of another triangle and 3 sides congruent to 3 sides. So we have 6 statements of congruency in here. And so at the beginning of the lesson we talked about that triangles, if all 6 corresponding parts of triangles were congruent, then the triangles would be congruent. And by this, what we've proved here is the definition of congruent triangles. All right, so that concludes lesson 4.1.